Hello students, today we will go to the next topic of the units and dimensions. The topic is applications of the dimension analysis. This is one of the most important concepts for the competitive examination problems purpose. We have three applications most important here. The first application, if you see this, already we taken on the board, to convert the system of one into other system of unit. Means we have physical quantities. Every physical quantities we are representing with the magnitude and its units. The units can be represented with the different types of systems. Last class we discussed like CGS system, FPS system, MK system, and SA system. Here what we are doing is we can able to convert the one system of unit to another system of unit using the dimension analysis. Like okay, 1 gram is equal to how many kgs, you know that, and 1 kg is equal to how many grams, you know that, and 1 meter equal to how many centimeters, you know that, right? Using the basic conversions, we are finding the big physical quantity conversion of one system of unit to other system of unit, so that what happens is in the examination you can able to solve the problems easily by converting using this first method. Second method is to check the correctness of the equations. So what is a, we have many types of physics equations are there. Okay, that physics equations we can able to explain which is correct, which is wrong. That can be able to check it. We can be able to verify using the second application. And third one, to find the relation between the physical quantities. That means you don't know the formula for the particular physical quantities. You can find the formula using this one. You can find the relation between the physical quantities here. But while you are applying this one, there is a certain limits are there while using the dimension formulas. What are that limits? The limits are you can apply the dimension formulas up to 3 physical quantities. You cannot apply more than 3 physical quantities. That means mass, length, time based, we can solve it easily. More than okay 3, it is difficult. We have to go for different methods of approaches to solve the problems like that. So here also last application is most important. In the some types of competitive examinations, if you don't know the formula, you can derive the formula using this method. If you practice very well in a short time, using that you can find the relation, you can find the formula, and using the method you can solve the problem in the examination. Now we will discuss the first application, that is unit system conversion, one system of unit or the system of unit. Before that, we have to know, okay, the physical quantity which are taken, that physical quantity we can write in terms of magnitude. That magnitude is called as number, and we are representing with a unit that we are calling as unit. So every physical quantity we can represent in terms of number and unit. So here what the unit system conversion is stating, that we can using the one of the basic formula. If any physical quantity, if we are expressing in one of the system called as CGS system, if we say, according to that one, it is having of its own number, that is n1 like, of its own unit nu1 like. Suppose the same physical quantity if you taken in terms of MKS unit, MKS system, if you taken, in that case it is having number n2, that number may be different, and the unit is u2. The what the conversion stating is the number into unit is equal to number into other system into unit is remains same. So n1 u1 is equal to n2 u2. Using this formula, you can find any number of the physical quantity in terms of previous example. Okay, if you come across just a simple way, 1 kg is equal to nothing but 100 grams. Sorry, 1000 grams, right? 1000 grams. So 1 kg is equal to 1000 gram means this 1000 is one of the relation. How you got it means using this analysis we can able to get it. And 1 okay meter is equal to 100 centimeters. These are the basic things we know that. That's why we are writing here directly. So these are the conversions. 1, that means 1 is the number, meter is the unit, 100 is the number, centimeter is the unit, meter is the unit in MKS system or SS system, centimeter is the unit in CGS system. So both systems are different for the same physical quantity of length, same physical quantity of length. If you see the number in the MK system, the number is 1, but in the case of CGS system, the number is 100. So 1 is not equal to 100. So the number may be different and the unit may be different, but the product of the number and the unit will be remains same according to the system conversion. So using this one, you can able to solve okay the any type of physical quantity conversion from one is a system of unit to another system of unit. We'll go for some examples. That examples we'll discuss Now here we will discuss the example, that is first one. 1 joule is equal to how many how much value of ergs, means joule is the one of the physical quantity which we are measuring for the work. This is the work unit and this is the value for that one. And how many ergs? Ergs is the same physical quantity work in CGS system. So already I told in the previous class you have to learn some tabular column, okay, units and the dimension formulas you have to verify little before. So here 1 joule is equal to how many ergs? To calculate using the first dimension analysis method we can able to do it, and in this case the application to convert here. First I am using the formula N1 U1 is equal to N2 U2 is the formula. Compare according to dimension analysis. Okay, number into that is unit of that one is equal to constant for a particular physical quantity. So N1 U1 is equal to N2 U2. Now what is N1? Compare here. In the place of N1 we have a 1. U1 is unit of that physical quantity in one of the system, that is called as in this case MK system, that is U1. And how much ergs, how much value of erg means question mark, that N2 value we need to find, and U2 unit of that system is ergs. So ergs is a CGS system. So we are converting, we are finding the value of the CGS system. We are finding the value of the CGS. So finally you have to get the result of the CGS. So further from the formula N2 is equal to what I can write? N2 is equal to that is N1 U1 by U2. First do this step. Then after apply the things in this. How to apply the things here? First, if you observe here, N2 is equal to what is N1? N1 is equal to, compare this one, that is 1 into what is U1? Unit. Unit is equal to joule by what is U2? U2 is equal to erg. So here you can't solve it using this one. So that's why in the fundamental relations we need to find here. How to find the value using the fundamental relation? First, joule. First try to write the joule in terms of fundamental units. How to write the joule? Joule is nothing but work, already we told. Work is nothing but force into displacement, already yesterday we done. So force nothing but mass into acceleration, like that we can write. So dimension formula for the force, dimension formula for the force we can write as mlt minus 2 is the dimension formula for this, into distance is here. So the joule dimension formula becomes ml square t minus 2 becomes. Now that means this m is called mass fundamental, okay, of the joule. That mass we are measuring in terms of kg because joule is a SI unit. In the SI unit we are measuring the mass in terms of kg. L is called length. Length we are measuring in terms of meter, that is meter square. Time anyway seconds, that is second minus 2. This is the way you have to write. Joule we can write in terms of SI unit like this. Similarly erg. Erg is nothing but CGS system. So joule is SI system means erg is CGS system means the mass we can write in terms of CGS system. What way? In the place of kg we are going to write gram. In the place of length, length we written meters in SI unit, but in CGS you have to write as centimeter square, and time is anyway that is second minus 2. Now apply this one in this formula. So we are going to get N2 is equal to nothing but that is 1 into anything is nothing but the same quantity you will get. So I am writing here directly kg meter square, that is second minus 2 by that is gram centimeter square, that is second minus 2, because the time measurement any system is seconds only. So that's why. So N2 is equal to, now to find the N2 value first, our question is in CGS system. So here this is MK system, the denominator value is MK system. Convert it into CGS system. What way we can convert? In the denominator we have first one is kg. What we have? This is kg. Kg we have to convert into CGS. Before doing this one, you have to know that 1 kg is equal to how many grams? That is 1000 grams. 1000 I convert as 10 cube grams. This kg I am written as 1000 grams. Next, meter. So 1 meter is equal to how many centimeters? 100, that is called 10 square. And we have a square, m is raised by 2 times. That means in this case I convert as 10 square whole square. That is in terms of centimeters. 1 meter is equal to 100 centimeters. So that is centimeter square I can write. Next, second, time is anyway basic value is second only. So that's why we can write that is second minus 2. In the denominator, no need to convert because our answer is required in CGS only, that is gram, centimeter square, and second minus 2 is the fundamental way of writing the unit. Now you can cancel here. So in this case, I can cancel here as gram get cancelled, centimeter square, second square cancel. So I can write this value in terms of n2 is equal to what I can write, that is 10 cube into this is 10 power 4. 2 square means 4, 10 power 4, nothing is there means 1, that is nothing but 10 power 7. So if you replace that value, 1 joule is equal to how much? In the place of question mark, I can replace with the 10 power 7. So 1 joule is equal to how many ergs? That is 10 power 7 ergs. Like this, we can able to convert from one system to other system. Now we'll take the one more example, that is 1 dyne. 1 dyne is equal to how much value of newtons? Means 1 is the number, dyne is the unit for force in CGS system, and n is the newton, is the unit for same force in MK system. So we need to find the SI value. 1 dyne is equal to how many newtons? To find that one, first this is you can write in the formula like N1 U1 is equal to N2 U2, like you write it. So in the place of N1, 1, in the place of U1, that is dyne, in the place of N2, question mark, in the place of U2, that is Newton. So now solve this one to get our result. So N1 is equal to how much? That is 1 into U1 is nothing but dyne we have, and is equal to N2 is equal to question mark, we don't know that, unit of U2 is equal to nothing but Newton. Yeah. So our requirement is N2. N2 is equal to what I can write, that is nothing but dyne by I can write as newtons. So write the dimension formula for the Newton. Newton is nothing but related to force. Newton related to force. What is the force dimension formula? MLT minus 2 is the dimension formula for the force. So this force, if you are expressing in terms of, that is MK system. Okay, that M mass can be written as in terms of kg. Length I can write as meter. Time I can write as second minus 2. Similarly, the same force that I can write in terms of CGS system. Okay, the force we are measuring in CGS system is dynes. If you are writing for the in terms of fundamental, the mass can be written as in terms of gram, length can be written as centimeters, time is anyway same, that is second minus 2. Put these two values here, that means N2 is equal to, I can write as dyne is equal to what I can write? Gram, centimeter, second minus 2 I can write by Newton. Also I can write in terms of kg, meter, that is second minus 2. So here our requirement conversion is, which related conversion this is MKS. So don't do okay to the MKS, convert this CGS, convert this CGS into MKS. Convert this CGS into MKS. So N2 is equal to, I can write as gram. So gram you have to write in kg. Already you have to know that 1 kg is equal to nothing but 1000 grams. That is nothing but 10 cube grams. Now that means 1 gram is equal to how many kgs? That is 1 by 10 cube kg. So 1 by 10 cube, if you make it up, it becomes 10 power minus 3 kg. So this gram I have written in terms of 10 power minus 3 kg. Similarly, centimeter. 1 centimeter equal to how many meters? 1 meter equal to 100 centimeters. So 1 centimeter equal to 1 by 100. 1 by 100 means that is 10 power minus 2. That is centimeter is equal. Second, time anyway, that is same, that is second minus 2. Denominator also we are not going to modify because our requirement is conversion of CGS only. Kg m into, that is second minus 2 is the formula. Now you can cancel it whatever requirement. Here kg get cancelled, and here we have a small error here. This is centimeter, it is not the centimeter. What is this one? This is meter, because we converted already in terms of, this is meter, right? So if you cancel this one, this meter get cancelled, second square get cancelled. After cancellation, N2 value how much you are going to get? N2 is equal to 10 power minus 3, 10 power minus 2, that is 10 power minus 5 here. So the answer for this question I can write in the place of this, what I can write in the place of question mark, I can write 10 power minus 5 newtons. So 1 dyne is equal to how much? 1 dyne is equal to, that is 1 dyne is equal to 10 power minus 5 newtons is the answer. Like this is a basic only, very simple, but starting we need to understand clearly. That's why we are going a little slower, and you have to understand, you have to practice this one. If you are getting practice, then you can accelerate to the higher level, and faster way of procedure can be followed to understand the problems. Now, second application is checking the correctness of the equation. So using the dimension analysis, we can able to check the correctness of the equations. Is the equations are correct or not? Physics equations. If you are taking the wrong formula, that you can able to verify using this uh, checking the correctness of the equation. That means you can use the dimension formula to check the correct or not, like that. So in this case, first we are going to know the certain procedure to understand how we are going to check. Example, we are going to take basic one of the formula. V is equal to U plus AT is one of the kinematic equation I taken here. So it will come in the further classes, or if already learned in the previous classes, that is well better. V is equal to U plus AT is one of the kinematic equation, where V is the physical quantity called as final velocity, U is called initial velocity, A is called acceleration, T is called time. So here, this physical quantity equation V is equal to U plus AT, how you can say that it is correct? That can be checked using dimension analysis. What is dimension analysis stating that? According to the rule of the dimension analysis, if the equation is correct, that means if you see this equation, the equation contains two parts. The equation contains two parts. This is two parts are two terms, I can say. Two terms are two parts, right? So here this is called first part, this is called second part, right? So in this case, two parts which are there, the formula which is given here, dimension formula left side, okay, this velocity physical quantity dimension must be equal to first term. The dimension formula of the physical quantity of left side, that must be equal to second term. That means separately the dimension formula for the first term must be equal to left side physical quantity. The dimension formula of the second term must be equal to dimension formula of the left side physical quantity. Then only the total equation will be correct, we can say. You cannot judge that by only one uh, term. If it is correct, the second term is not correct, then that equation is not correct. If all the terms which are present in that, if it is okay, equal, balancing both the sides, the left side and right side, then I can say that equation is correct. So in this case, one more thing you have to understand while checking the correctness of the equations. So here, this is velocity, right? And U is also velocity. And AT is two different physical quantities. Here we are multiplying here. So sometimes we are getting the equations in terms of addition. Sometimes we are getting the equations in terms of multiplication. Sometimes we are getting the equations in terms of division, like pressure is equal to force by area. Like that, we have different types of physical quantity formulas are there. So here our requirement is to understand, to check the correctness of the equation. There is a trick will be there. The trick, if you understand, so higher level problems can be done very easily. What is that one? This is velocity, right? This is also velocity. So the second term, it is AT. That AT also, if this equation is correct, if you say the AT also must be equal to velocity, then only it is correct, right? According to our concept, right? That means here you need to understand here, any equation, if it is they are saying correct equation, that means the both, okay, addition, either addition or subtraction or division, that physical quantities must be similar one, same one. So example, if you see this one, in this case, first term, second term, both are, if you are saying correct, that means both are individually correct with a V. So that means then only you can able to add. That means you can add the number to number. You cannot add to the number to alphabet, right? 1 plus 1, you can add it, 1 plus 2, you can add it, 1 plus 10, you can add it, but you cannot add it to 1 plus C and 1 plus C. So here similarly, in the same way, the velocity physical quantity is left side, and right side we have two addition terms are there. In these two terms must have same type of quantities. Both are velocity, then only you can add it. If both are pressure, then only you can add it. Both are force, then only you can add it. That means two different terms cannot be possible. If you find two terms are different, then that is not a correct equation, we can say. Basing on that one also, we can solve some physics problems in this. Now we'll go to the procedure to check the correctness of the above equation. What is V? Velocity. So first, whenever you are doing, the left hand side dimension must be equal to right hand side dimension of the each term. That is compulsory condition. each term. And second point you have to remember, you can add the two physical quantities or you can subtract the two physical quantity which are similar ones only. If they are not similar, that equation may not be correct. You cannot add it, you cannot subtract. So in this above equation, whatever it is given, v is equal to u plus at. Now we are going to verify this one, either it is correct or not. First, to check that one, this is the first term we are calling. This is second term we are calling. According to our basic, the left hand side physical quantity dimension must be equal to first term of the right hand side physical quantity. That means the dimension of the v must be equal to u. So what is the v? V is called velocity. The dimension of the velocity is Lt minus 1. That you have to practice before doing this procedure. Now what is u? U is also velocity, but what is the difference? This is final velocity, that is initial velocity. So u is also velocity, the dimension is same, that is Lt minus 1. So left side equal to right side. Left side dimension formula is equal to right side dimension formula. That's why it is correct. Next one, second term. It is, we should not decide that it is total equation is correct. Second term has also has to be equal. So what is left hand side? That is velocity. Right hand side is a into t. Now this a into t, a is nothing but a, one of the derived physical quantity. That at I can write in terms of fundamental quantities like. Otherwise, if you know the dimension formula, you can do it like this. Velocity dimension formula Lt minus 1, left hand side. What is a? Acceleration. Acceleration dimension formula already we learned in the previous. That is Lt minus 2 into. We have one more term is that is called t. T is called time. That is t power 1. So if you observe this one, Lt minus 1 is equal to, this is t power minus 2, t power plus 1. Minus 2 plus 1 is minus 1. That is Lt minus 1 unit. So both sides dimension formulas are equal. That means I can say the above equation which is given is correct. Like that we can go for some other example. One more example will go, and then we'll proceed to the third application. This example is given in the previous IITG 1997 question. This is very simple, you can understand that, but only how we are applying the concept to solve the problem. What is given? They given one of the equation, van der Waals gas equation, we are calling this one. This equation contains P plus A by V square into V minus B equal to RT. The terms where P is called as pressure, A is constant, and V is called volume, and this is also volume. B is called constant, R is called universal gas constant, T is called temperature. Now what the question they're asking in this case, they're asking to find the constant A value is equal to how much? Constant B value is equal to what is the dimension formula for A? What is the dimension formula for B? They're asking to find from this. Here, according to given, so just the second application is to check the correctness of the equation, right? So is this equation correct or not? They given already equation is equal to RT. Using this, they are asking to find AB value, means this equation is correct according to their. So that means according to correctness, this equation is correct. Basing on that phenomena, we are going to solve the problem. In this case, already I told that this is contains term. This is main first term. This is second term. Again, if you see this one, the one term again contains another separate two terms. P is the pressure plus there is a A by V square. There are two other terms. So always in physics, you can add pressure to pressure only, velocity to velocity only, like that I told just before. So here also the first term is pressure. The second term A by V square is looking different, but you can add pressure to this A by V square, means I can say simply this pressure value is equal to A by V square. Both are same one. That is the meaning of that. Second term, if you see that V minus B, we need to find the B value. V minus B means you can remove the one of the physical quantity, with a similar physical quantity only. You can't remove another physical quantity. That means volume minus B means B is also related to volume only. B value also volume only. So using this, you can find the dimension formula for this. First question, what is that? The A value, the A dimension formula. From this P is equal to A by V square, because pressure can be added to pressure only. So second term A by V square also pressure I can say. So pressure is equal to A by V square I can take. So small a is equal to, I can write as P square. So what this P is called pressure. Pressure nothing but we can write as force by area into V square. So now write the dimension formula for this one to write the A value. A is equal to dimension formula for the force is ml t minus 2, already we learned in the previous, by area dimension is L square into volume, volume nothing but L cube, and we have a square is there, that means whole square. That means it becomes L power 6. So if you write this one, I can write as mlt minus 2. Okay, this is 6 and this 7 becomes, and this is L square. Now here L value I can cancel it. Here this is 2, this is 5, this is 5 left, right? Remaining is you can write as, that is m L power 5 t minus 2. So the dimension formula for the A value will becomes equal to ml5 t minus 2 is the dimension formula for the constant. Using correctness of the equation, you can able to find it like that. Second one, find the B value. B value also similar. So B value is equal to how much we got? Equal to V. So B is equal to, what is V? Volume. Volume nothing but L cube. Directly we can write it as the dimension of the B or the value of the B is equal to L cube. This is a question they asked in the previous. The next example is also a IITG question, 2004 question paper given. Pressure depends on distance. Equation given P is equal to alpha by beta, that is exponential function of minus alpha z by k theta, where alpha and beta are constants, z is called distance, k is Boltzmann's constant, and theta is temperature. And they're asking to find the dimensions of the beta. So if you see the equation here, first I'm writing the equation here, P is equal to alpha by beta, that is exponential function nothing but E, okay, that is exp, we can write exp into, that is minus alpha z by k theta. Now here we need to understand exponential function according to dimensional limits, exponential function not having any dimension formula. So this no need to take any dimension formula for this. It is not having dimension formula. So I can write simply P is equal to alpha by beta. To get the beta value for our question, beta is equal to simply, okay, I can write alpha by pressure. So you need to find the alpha value. Here in the question, alpha is also a constant, but P is pressure. So we can find the dimension formula for the P, but alpha is constant. So they did not given the alpha value in the question. So we need to find first alpha value in the question. How to find the alpha value? If you see the second, this one, this, okay, exponential function not having dimension, nothing but we are not, P is equal to alpha by beta, we are taken means we multiply, we take an exponential function completely as 1, right? That means the bracket term which is there, already I told, no, what is I told just before, this is the one of the, okay, alpha beta, one of the product of two physical quantities, this is product of two physical quantities, we are dividing. So dividing means this is nothing but 1, okay, this division value we are getting 1 according to our derivation. This division value becoming 1 means I can write here alpha into z value must be equal to k theta, then only we will get the 1 value. Otherwise if both are different values, we won't get the 1. And exponential, that means the physical quantity of relation alpha into beta value must be equal to k theta. From this we need to find the alpha value. What is alpha? Alpha is equal to k theta by z, we can find. Now find the k value. What is k here? In the question very clearly given, k is called as Boltzmann's constant. Boltzmann's constant formula, how to find it? According to gases equation, PV is equal to nRT is the equation. N is the number of moles. When you take in the gas in terms of number of moles, R is universal gas constant. When you take in the gas in terms of 1 mole of gas, when you take in the N value is equal to 1, in that case we can write as kBT. So PV is equal to kBT. From this kB, Boltzmann's constant kB is equal to, we can write as PV by T. This is a formula for this. Now we can write the kB dimension formula. Kb is equal to, because to get the alpha, we have to know kB value, that is kB value. To get the kB, PV by T value, we have to find. What is P? P is the pressure. The pressure dimension formula just before we done. So using this one, we can find the pressure dimension formula. That value I'm writing here, that is M L minus 1, that is T minus 2 is the dimension of the pressure into, and what is V? Volume here, volume is equal to L cube by, what is T here? Temperature, that I am writing as theta, because it is also one of the fundamental quantity according to SI system. So in this case, this kB dimension formula I can write as what I can write, that is nothing but m into L square ml square t minus 2 into theta minus 1 I can write. This is the dimension formula for kb. Now that kb value substitute here, so then what you are going to get the alpha value. If you substitute that one, you are going to get the alpha value is equal to, what is alpha? K. What is k dimension? That is m L square, okay, t minus 2 theta minus 1, okay, into theta by z. What is z? In the question very clearly given, z is nothing but called as distance. Distance always we are measuring in terms of length L. So here I can cancel the certain terms. My theta minus 1 plus theta, we can cancel it. L, 1L we can cancel. So remaining is alpha value is equal to ml t minus 2 here. This is alpha. After getting alpha value, substitute that alpha value in this given question. So what is our question? They're asking to find the beta value. Beta is equal to alpha by p. So alpha value is equal to m. So first I'll write that alpha by p. So what is alpha? That is nothing but mlt minus 2 is alpha value by, what is p? Pressure. Pressure dimension already we done here just before also. This is the nothing but pressure dimension, that is ml minus 1, ml minus 1, t minus 2 is the dimension. So what I can cancel here, if you check it, this one, this m get cancelled, t minus 2, t minus 2 get cancelled. So beta value must be equal to, in this case, we got here L power minus 1, denominator if comes up, it becomes plus 1. That means already we have 1, 1 plus 1 becomes 2. So this value you are going to get, beta value you are going to get is equal to L square. Beta is equal to L square L. So what is the beta value here? That is L square. So the dimension formula for this one, if you check the options, first one m0 L0 t0, it is not correct. Second one m minus 1 L minus 1 t minus 1, not correct. Third one is m0 L square t plus 2. So see, we have L square. So this is the correct option. Last option m minus 1, anyway we are not having m. So the correct option, okay, answer for this question is m0 L square t0. This is the way you have to solve the problems for this using the, okay, checking the correctness of the equations based problems. The last application is finding the relation between physical quantities. Most important dimension, okay, application. Using this one, you can find the formulas which you don't know that in the competitive examination. If you practice this one very faster, you can find the formulas, and also you can attempt some objective questions using this units and dimension third application, finding the relation. So here we are taking one of the example here to understand that relation. So you know the one of the relation, time period of simple pendulum. The time period of simple pendulum 2 pi root L by G is the relation. This is the formula already we are going to learn in the topics. Okay, here initially starting, you keep it in mind that you don't know the formula, you don't, okay, did not remember this. So that means what is the formula to T L G relation, how to find it? So that means that T is called time period here, how this time period is related to length and time. So here the T is proportional to length and gravity, like this here. So we don't know that how it is related, that in the formula actually we got, then we check it using the correctness of the, okay, finding the relation between using dimension methods we will try. So here T is proportional to L into G. So you have to take it like this. L, length, how much the power of the length is raised, you don't know, you take it as A. Gravity also, how much it is raised, we don't know that you take it as B. So T is proportional to L power A, G power B. So remove the proportionality, keep a constant called as K, K into L power A and G power B. Now to find the relation between the T, L, G, we need to find the A value and G value. To find the A value and G value, first, before left hand side physical quantity dimension must be equal to right hand side, okay, dimensions we have to write. Then after we have to compare the certain things. Just first I will write the T. T is called time period. The time period dimension formula is only, that is m0 L0 just a T. This is the dimension formula for time period T. Next, what is K? K is called as constant. Constant not having any dimension formula. There is no dimension of that one. No need to take 0 here. So just, okay, there is no dimension here. K is not having dimension formula. So it is a constant, just you can keep a number like. What is L? L is called length. The dimension formula for the length is equal to m0, that is L1, T0 you can take. And next, if you come across a case of G, G is called acceleration due to gravity. The G is nothing but acceleration. Acceleration dimension formula is m0 lt minus 2. Before solving this, you have to know the dimensions of the each physical quantity. Otherwise, you can't proceed. That's why you have to learn well before solving this. So now I am going to take the dimension formula of the left side one. Left side is time period. The time period dimension formula I am writing as m0 L0, that is t power 1, is equal to k is not having any dimension, L. What is L dimension? That is nothing but, so m0 t0 no need to take, just you take it as L power n, L power 1 whole power a I can take, because L is the dimension, okay, length dimension is L, but the power is raised by a, so I can write as L power 1 whole power a. And into next, what is that? G. What is G? Acceleration due to gravity. This is the dimension of that one. That dimension also m is 0, no need to write this one, so directly I can write as lt minus 2. The power of this G, how much it is raised? To find the relation B, we don't know that value. So because dimension formula always expressed in terms of fundamental quantities with a certain powers raised. If you know the powers raised, you can find the relation exactly. So first, how to do it? Compare the right side mass powers and left side mass power. This is left side, this is right side, right? So what is the power of the mass of the left side? That is 0. And right side, we have any mass here? There is no mass, so 0. No need to bother about much. And next, second physical quantity. The left side length physical quantity power is raised by 0. Okay. And right side is, if you see this one, right side is how much? Length power 1 whole power a. That means 1 into a. How much? We are going to get a. Next, here L is there, one more L is there, L power B, that becomes LB. Here L power A, L power B. So bases are same, as powers must be added. When the bases are same, powers you have to add. That means this is becomes A plus B. So from this, we are going to get the relation A is equal to minus B. So A value is equal to B value, but it is opposite of. Next, what is B value? To find that one, next go to the next, third one. What is third? Left side dimension of the time is t, you take it, that is equal to, left side dimension of the, okay, t is equal to 1, power is raised by 1. Right side t power is raised by how much? That is minus 2 into b, that is nothing but minus 2. From this, b value is equal to what I can write? Minus 1 by 2. So you got the b value. When you got the b value, now go reverse way. Substitute that b value here, then you will get the a value is equal to, already we have a minus of minus 1 by 2, we are going to get plus a, that is a is equal to plus 1 by 2. So a value got minus 1 by 2, b value got plus 1 by 2. Now these a, b values substitute in the given equation, okay, that is time period of simple pendulum equation. Time period t is equal to, that is constant k into L power a. Yes or no? L power a. What is a here? L power a. What is a? A value is equal to plus 1 by 2, that I am taking as 1 by 2 here, into g power b. B value how much? That is minus 1 by 2, that is minus 1. This g power minus 1 by 2, if you make it to the denominator, it becomes k is equal to k into L power 1 by 2, I can write, by, this is g power plus 1 by 2, I can write. Minus 1 by 2, if you make it to denominator, it becomes plus. Now this, both terms having 1 by root 2, 1 by 2. 1 by 2 means what? Power of 1 by 2 means it is nothing but square root. So it is also square root value, it is also square root value. Both we can take it as square root. Before that we have a k into under root of L by G, because root value is nothing but 1 by 2, L power 1 by 2, G power 1 by 2. I taken a common, that common I written as L. What is this case called? Constant. This constant is depends on practical. That practical value is identified by scientists is 2 pi root L by 2. This is the way you can find the formulas using dimensional analysis. This is one of the most important applications. We'll go for one more example for this. Next example, this is the equation which is given. Fv is equal to 6 pi eta Rv. This is one of the concept related to viscous force. This is most important equation which is used in the Millicon oil drop experiments like secondary electrostatic, okay, that related problems can be Okay, done using this formula. So viscous force equal to 6 pi eta RV is already formula is there. Now we are finding, you don't know that formula, we are going to find the relation here. So force of viscous, how it is related to eta, how it is related to R, how it is related to V. Eta is raised by, you don't know that A, here we don't know that like B, you take it as B like, and velocity is C like. In the answer we have 1, 1, 1, that we are going to prove. Okay, so force of viscous is proportional to eta power A, R power B, V power C. So remove the proportionality, keep a constant, that is K into eta power A, R power B, and that is V power C. Now before solving this one, you have to know the dimension of each physical quantity. I have written already here, you can check it this. What is eta called? Coefficient of viscosity. The dimension formula for this one is ml minus 1 T minus 1. This formulas you have to learn before. Okay, solving this one. Next, what is R called? Radius. Whenever we are dropping any spheres into the liquid, the motion of the liquids, the motion of the bodies are explained in the basing on viscous force. R is called as radius. The radius we are measuring in terms of length. What is V? Velocity. That velocities of the bodies inside the liquids we are calculating using the formula LT minus 1 is the dimension of that. And what is force of viscous? It is a force. So MLT minus 2. So apply here all the terms. If you apply left side, force is I can replace with MLT minus 2. So ML means M power 1, L power 1, T minus 2 is the left side one. Is equal to K is constant not having any dimension, no need to write. Eta, what is eta dimension? That is M L minus 1, and that is T minus 1. We can write ML minus 1, T minus 1, we can write it, and into this is power is raised by how much? That is here. Next one is R. What is R? Dimension is L. That L is power is raised by how much? That is B times. Next one is velocity. Velocity dimension is LT minus 1. Okay, the power of this one is raised by how much? That is C times. Now compare the power of the masses of the right side with the left side comparatively. So left side mass is raised by how much? 1 is equal to right side mass is how much? This mass nothing is, that means 1. 1 into A, that is nothing but A. There is no other masses present. So A value is equal to 1. Already we got the 1 value here. Next, compare the length. Okay, this side length power is 1 and right side length power is, this is minus 1 into A minus A. This is nothing is a 1. 1 into B means nothing but B. This is 1. 1 into C nothing but C. So bases are same means power must be added. That is nothing but minus A, and this is plus B plus C. Now put the A value here. If you put the A value, 1 is equal to, that is minus 1 plus B plus C I can write, because it is a better way to practice immediately there itself only we can, that value is equal to become 0. Minus 1, if you make it this side, it becomes okay plus 1. Plus 1 means how much? Already 1 is there. 1 plus 1, 2 it becomes 2. So B plus C is equal to 2 you are going to get. Now you can't solve it because B value you don't know, C value also we don't. Go to the next one, third one, time. So the time dimension of this left side is minus 2. Right side dimension is minus 2 into A, that is nothing but minus 1 into A, nothing but minus A. There is no time here. There is a time. Minus 1 into C, nothing but minus A. So here minus 2 is equal to minus A minus A. Now here 2 is equal to B plus C. So what is A value? 1. If you put the A value 1, minus 2 is equal to minus 1 minus C. So from this I can write the C value. What is the C value? C is equal to nothing but minus 1. This, if you bring it this side, it becomes plus. Minus 2, if you bring it this side, it becomes plus. So minus 1 plus 2, nothing but plus 1. C value is equal to how much? Put the A value 1 and the C value 1. That means if you put the C value here 1, if you come across backward, that is B plus C is equal to, B plus 1 is equal to how much you are going to get? B plus 1 is equal to B plus 1 is equal to 2 you will get. From this I can write B is equal to also 1. So A value is equal to B value is equal to C value is equal to, all are got same. So that means the viscous force is equal to K into eta power 1, R power 1 and V power 1. So I can write the formula simply. If viscous force equal to K is constant, that is experimental Least scientists given constant is 6 pi, 6 pi eta r is the formula. Like this, we can find the relation between the physical quantities using dimension analysis. Third application.